Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is our next installment to inverse functions. Today, we learned how to start taking the inverse of equations, specifically linear and quadratic. So hopefully that'll all make sense this week. We're gonna put it all together. Now, please know next week is most likely going to be a review week. So, do your best that you can, and we're gonna give you an extra week to get caught up. Let's go ahead and let's just dive right into it, right? We got nothing else to do. Last week, we spoke about inverses, right? This idea that an inverse is an opposite order of operations. So for example, if I add, the inverse is subtracting. If I multiply, the inverse is dividing, right? So you could see the inverse is just the opposite. It's kind of like what helps cancel out the original, because it undoes everything that the original did. If I take 4 steps forward, my inverse takes 4 steps backwards. And so as a review from last week, if you look here, this is a review from last week. Well, what was our definition of inverse? Well, an inverse did 2 things. One, in order to find the inverse of a table, you had to flip the x and the y value. So if you look down here, right, my x value was -4, 0. Well, now it becomes 0, -4. So just as a reminder, inverses, you need to basically flip your x and your y, your inputs and your outputs. And then also a very special thing about inverses was that they reflect over the line y equals x. Now, why do they reflect over this line? Well, they reflect over this line because that's just what ends up happening when you switch the x and the y's. The points are being essentially reflected over this line. So you can technically fold them, and the distance is the same from here to that point, right? You can see that point distance to this point distance is the exact same. So let's go ahead and use that idea to find equations. So let's start off with something nice, something kind of basic for the most part. So let's write y is equal to 3x. If I want to find the inverse of this function, I need to still do the very first thing that I did with tables. I need to switch the x and the y. Now that may seem strange, but all that means is wherever the y was, the x will now go, and wherever the x was, the y will now go. So this is how it's going to look like. If this is y, this becomes x is equal to 3 times y. So notice all we did was we took the y and we put it where the x was, and then we took the x and we put it where the y was. We've switched the x and the y in the equation, just like we did with tables. Now we're going to solve for y. Why are we solving for y? Well, I'll explain to you in a moment. Well, if we solve for y, we're going to divide both sides by 3. So if we divide both sides by 3, these cancel. We're going to get y is equal to x over 3, and then just because it's weird to write it this way, I'm gonna come over here and write it like this: y is equal to x over 3. This is really nice, right? So for example, if my original equation was f of x is equal to 3x, exactly what I wrote up above, this is what my original does. Well, what does my inverse do? Well, my inverse, remember we put this little -1 up here to mean inverse. It doesn't mean raised to the power of -1. It's just representative of inverse. Well, when we did the inverse, we switched the x and the y's and we solved for y. Our inverse was x over 3. Now I want you to think about, does that make sense? And it should, hopefully. If my original multiplies by 3, what should my inverse do? Well, my inverse should divide by 3. So look over here, when we switch the x and the y's and we solve for y, we got x over 3. We're dividing by 3 instead of multiplying by 3. So you can see these two are the exact opposite of each other. They're inverses. If you do one thing, the other one does the exact opposite. And so if this is my original, with our new notation, this is my inverse function right there. So just a little example of how to find inverses with equations. Let's go to a little bit of a tougher one. So here we go. Find the inverse of the equation below. Find the inverse find the inverse of the equation below. The inverse and the original are already graphed for you. Well, just as a fresh reminder, 4x plus 2, the 2 is my y-intercept, so my 2 is my y-intercept right there. And the 4 is technically 4 over 1, so that's rise over run. So we go up 4, 1, 2, 3, 4 over 1. And then up 4 over 1. So you can see that this line here is my original. And if I draw the line that it reflects over, remember we spoke about this line right here, y equals x. Every inverse is inverses reflect over this line, you're going to see that this line over here has to be our inverse function, right? It has to be our inverse function right here. Now, if you look, the y-intercept looks to be half. 0.5. So obviously a little bit tough, right? So we need to go ahead and find it and see if we can then determine what it is. So find the original, find the inverse of the equation below. So let's now bring it up a notch. How do we go about doing this? Well, we're going to do the exact same thing that we did in the previous, or in the last example problem, right? Let's go ahead and write this as y equals 4x plus 2. Now, if you remember, what is our first step whenever we want to find inverse functions? Well, our first step, no matter what, is to switch the x and the y's. So this is going to become x is equal to, I'm going to change colors in a second, 4y plus 2. So we get this, right? Remember, our job is to always switch the x and the y's, even in a graph and table, and we do it with equations as well. So we're going to swap these. Now we're going to solve for y. We want to undo everything, right? To find the inverse, if my function multiplies, I need to divide. If my function adds, I need to subtract. So I'm basically putting and switching these because that's one definition. Two, to basically give me the equation that'll do the exact opposite, the inverse. Well, how do we solve this equation? Well, we're going to subtract 2 to both sides. All right, these colors are not very dark, but that's okay. We're going to get x minus 2 is equal to 4y, like this. Boom. And then now what do we do to get rid of the 4? Well, we're going to divide by 4. Okay, and there's two ways of doing this. When you divide by something, you can do it to everything, or you can do it individually. So we're going to get x minus 2 divided by 4 is equal to y. This is now my inverse function. This is my new inverse function. Notice how it does the opposite. If this adds by 2, I'm subtracting by 2. If this multiplies by 4, I'm dividing by 4. So notice how it all kind of worked out. Now, if you wanted to graph this, you would now can write it like this. Just another way for you to write it. Y is equal to, you can divide these first. So it'd be x divided by 4. And then you can do minus 2 divided by 4. Divide by 4 individually. We're going to get x over 4 minus 1/2 if you simplify this fraction. So that's why if you look, negative 1/2 is your y-intercept, which is right here. And then this is going to go up 1 over 4. So up 1, so up 1 over 4. 1, 2, 3, 4. You can see it leads me right on this point. And I have to go up 1 very carefully because it's going by halves. Half, that's 1. Go over 4. There it is, and you can see that's where my inverse is at. All right, well, if you look right here, this was my original, y equals 4x plus 2. This is my inverse right here. Notice how it can get confusing because they both have y's. That's why we like to use a notation down below here. So instead of saying y equals, now we can write the inverse of f of x, the inverse of the original is x over 4 minus 1/2. That way we know which one was the original and then which one was the inverse. Now explain which line is the original and which line is the inverse. Well, we kind of did that in this video, right? This was the original and then we reflected it over the y equals x line, and here's the inverse. Or you can find the inverse and then you can go ahead and draw it, and you can see that they are in fact a reflection of each other over that line. Okay, let's go ahead and try one more that's a little bit more complicated. So we want to find the inverse of f of x equals x over 6 plus 4. Well, just thinking this through without even doing anything. If this adds by 4, what should my inverse do? Subtract by 4. If this divides by 6, what should my inverse do? Multiply by 6. So let's find the inverse and see if it all comes together. So we're going to get y is equal to x over 6 plus 4. Okay, I want you guys to know momentarily, I'm going to just momentarily write it as y equals so I can flip them easier, right? Because if I just have f of x and I flip these, it can get a little confusing with the f there. So I'm gonna just write y equals first and then we'll flip it. So we gotta flip the x and the y's. So this is gonna become x is equal to, the y goes here, so y over 6 plus 4. And now we can go ahead and solve this. Well, what do we do to solve this equation? Well, we're gonna subtract 4 to both sides, subtract 4 to both sides. Boom. We're going to get x minus 4 is equal to y over 6, which is really, really strange, right? We haven't dealt with this one in a minute. Well, what do we do to do this? Well, we're going to multiply both sides by 6 to undo these. Well, when I multiply by 6, I'm going to put a set of parentheses because the 6 is going to go out here. These cancel, and I'm going to get 6 parentheses x minus 4 is equal to y. And now I'm going to go ahead and distribute these across. 6 times x, 6x. 6 times negative 4 minus 24 is equal to y. And you can see that is my full simplified inverse function. Now, this one I think makes a little bit more sense if you want to compare the two, and I'll tell you in a moment why. So let me come over here. Remember, this is f, should be, I don't know what happened to this, it got cut off, so let me just rewrite it. The inverse of f of x, that's how it should be written, 6x minus 24. And then I always like to put a little dot in the middle just to remember that these are multiplying. Now, up here you can see if this is adding by 4, this is subtracting by 4. If this is dividing by 6, this is multiplying by 6. Obviously, we distributed it and it got simplified, but nonetheless, it's our inverse function. So here's our fully simplified inverse function. Now, explain each step you did to the problem to the left. Well, step 1, switch the x and the y's, right? So if you wanted to, I'll go ahead and annotate it. Switch x and y. So here are my steps. We switch the x and the y's because we're finding the inverse. We're going to subtract 4 to both sides to undo this right here. Again, we're finding the inverse, so we want to do the undo. We want to basically do the opposite order. And then we want to multiply by 6 to undo the dividing by 6. And then we want to distribute. So that was kind of the steps to putting this together. Let's go ahead and do one more together. That's a quadratic function. It's a little bit tough, but we'll be okay. Let's go ahead and take a look at this one right here. This one's a tough one. And this one's a really good one to do. Now, we want to find the inverse of a quadratic function. Before we do, just as good review, this equation is in vertex form because it's the one with the 1 parenthesis. It's completed the square. It has the power of 2 and the plus 1. So if you remember, what do I need to plug into here to get 0? Well, I need to plug in negative 4. Negative 4 plus 4 is 0. And then this is going up 1. So if you look for a moment, this is telling you that it's going to go to the left 4, up 1. Left 4, up 1. And here is my vertex. Right here. My vertex is right there at the minimum, and then I get this quadratic function. It's in vertex form. It's telling me the minimum point of this graph right here. Now, if I was to graph this, remember, it should be a reflection over the y equals x line right here. So it should be a reflection over this line, okay? So keep that in mind, that when I graph this, it should reflect over here. Now, I could do this the long way. I can make a table and then reflect it, or I can just draw the distance, right? 1, 2, 2.5. Half, 1, 2, so we know that this point should be here. Now I'm going to wait off on that for a moment because I'm going to do it with the equation, but you can see how we could graph this even without the equation. So let's go ahead and do this problem. Well, to start this off, we're going to do this problem just like we did every problem. What's first step to finding inverses? If we need to, I've cut out the instructions. It should have said find the inverse of this quadratic function. And so we're going to get y equals, remember, I always like to rewrite it. Y equals, and we're going to go ahead and write x plus 4. Okay, now we're going to go ahead and do exactly what we spoke about, which is switch the x and the y. So we always got to switch the x and the y's whenever we're finding the inverse of these functions. So the x goes where the y was, and the y goes where the x was. So here it is, raised to the power of 2 plus 1. Now we need to solve for y to undo order of operations and find the inverse. So let's subtract 1 to both sides. Shazam, like this. And we're going to get x minus 1 is equal to y plus 4. Now, this one's a tough one, right? There's no number in front here. If there was, say, like a 3, we will need to divide 3 to both sides, just like we did with a linear function. But since there is no number here, we're now going to go ahead and get rid of the power of 2. Well, if you remember, or maybe don't, so we're doing it together. What do you do to get rid of the power of 2? Well, we're going to take the square root of both sides. And I'm definitely changing colors. So we're going to take the square root of both sides like this. Boom. Now, when I take the square root of both sides, you have to be careful. I don't know if you remember this. When we take the square root, we get plus or minus. So we're going to get the square root of x minus 1 plus or minus. So we get the square root plus or minus the square root of x minus 1 is equal to y plus 4 because the square root and the 2 cancel out. And then we're going to subtract 4 to both sides. Now, when I subtract 4 to both sides, the subtracting by 4 does not go with the negative 1 because it is bounded by the square root. So this is how it's going to look like. We're going to get plus or minus. So we're going to get equal to plus or minus the square root of x minus 1 subtracted by 4 is equal to y, which I already have right here, right? This is, let me erase that. This is our inverse function, which we figured it out. So there is my function. Now I technically get two of them. I get the positive square root, x minus 1 minus 4, and I get the negative square root, x minus 1 minus 4. There you go. Well, if you take a look here, let's go ahead and graph these. And I know these are harder to graph and we haven't really done square root functions, so just bear with me. What do I need to plug into here to get 0? Well, 1. So this is going to go to the right 1 and then down 4. So we're going to go right 1, down 4. That is this point right here, which if you notice is it's reflecting perfectly with that blue point I just drew. Now this is the positive square root. So because it's the positive square root, that means the function is going to look something like this. Now obviously this isn't a perfect sketch, but it's going to look something like that. Technically speaking, if you notice, this point here is lining up with this point here. So you can see this bottom section and this bottom section go together. If I was to fold it over that line, this part of the quadratic equation is that right there. That's the positive one. The negative one is a reflection, meaning that it's going to be negative. So that means this one right here is actually going to be this bottom portion right here, like that. Now if you look, obviously it's not perfectly drawn, but this section right here ends up, when you turn it over, it ends up being upside down. It looks basically like it was reflected. That's where the negative comes into play, because it's being reflected. As you can see, when you take the inverse of a quadratic function, you get one positive square root and one negative square root. One positive is this up here, the other negative is the one down below here. And that's why you need a plus or minus. Another reason, because each square root tells you one part of the function, one here and then one here of our original quadratic function. So hopefully that makes sense. A little tough one. Next week is going to be review. So if you feel good with everything, check the pinned tweet down below. I put some challenge problems for you that we're not going to go over if you want to give these a try. So check the pinned tweet. They're my old videos that will give you some more challenge if you want it. So with that being said, y'all, hopefully that makes sense. I'm out. Take care. Capiche?